Alright guys, welcome to this page of the notes. So what we did is we just took a look at the midpoint formula and how we can use the midpoint to find exactly the center, the midpoint, the point that's halfway between 2 points on a coordinate plane. Now we're going to do our second objective is to take a look at the distance formula, how it works and where it comes from. First, where does it come from? Turns out the distance formula is actually the Pythagorean Theorem, and let me show you. What I've given you again is 2 points. The point P, which is farthest to the left, so I'm going to call it x1, y1, and the point Q, farther to the right, I'll call x2, y2. And what I want you to do is from this point P to this point Q, I want you to find that distance, which I've labeled D. Now, here's the way that we're going to do this. What you're going to do is you're going to go ahead, right? This point P has some x value, which we call x1. So let me drop this down here to this guy right there on the x-axis. That is x1. And then this point over here, Q, has some x value that's greater. We call x2. So let me drop that guy down here to the x-axis right there. There's x2. Now, how do I find the length of that distance? Well, actually, it's very simple. Take the bigger number, x2, subtract the smaller number, x1, and you can see that right there in the diagram. x2 minus x1 gives me this distance right here. x2 minus x1. But P also has a y coordinate, y1. So I'll trace that over to the y-axis, and that will give me the y coordinate, which we'll call y1. Q has a y coordinate associated with it that in this case is bigger. It's traced over to the y-axis, and I will call that, sorry if my lines aren't exactly straight, I apologize, it's somewhere right about there, y2. But once again, how do I find that distance? Well, actually, it's very simple to do. If I take y2, which is from here to the origin, right? y2 is that entire distance, and subtract from y2 this little bit, what's left over is the distance from y2 to y1, which is exactly what you can see here on the diagram. y2 minus y1 gives me this distance right here. Well, we know from geometry, if you have a right triangle, which I do, if I know the length of the sides, and I'm looking for, in this case, the distance, which is the hypotenuse, you can use the Pythagorean Theorem, which is simply c squared, that is the hypotenuse, c squared, is equal to a squared, one of the legs, doesn't matter, you can make this a squared or this a squared, doesn't matter which one, plus b squared. Right? But, right, I'm trying to solve for the hypotenuse, which means I want c, not c squared, so we just simply take the square root of the both. We'll take the square root of both sides. I wind up with the square root of a squared plus b squared. However, c, yes, I'm looking for a hypotenuse, but I've asked you to find the distance. So we're going to replace our value for the hypotenuse, our variable for the hypotenuse c. Let's just replace it with a d, since I'm looking for a distance. So d. And here's what I know. If this side is side A, well, what is the length of A? Well, A is x2 minus x1. So that's going to be x2 minus x1, and it will be squared since it's an a squared. So I'm telling you that my a in my Pythagorean theorem, a is equal to x2 minus x1, but then I have to square it. That means then that this guy will be my b, this is my b, which is plus y2 minus y1, and of course that will have to be squared since it's a b squared, and I have to take the square root of that whole thing. And cuckoo, ka-choo, look at what you just found. What we call the distance formula simply comes from the Pythagorean Theorem and using right triangles. You will find the length of each of the sides and use Pythagorean Theorem to find your hypotenuse. But instead of calling it the hypotenuse, we'll just call it the distance. All right, so what I've got for you guys is a number of example problems where we can go ahead and run through this. Again, I know you saw all of this in geometry, and everything I just went over with you should just be a refresher of what you did in geometry. But here we go. Again, I like to make the point farthest to the left, x1, y1. So of course 0 is less than 3, so this will be my x1 and my y1. This will be my x2 and my y2, and then we just start plugging and chugging. Distance is equal to, it is x2, which is 3, minus x1, 0, and that's squared. We add to that y2, which is a negative 4, minus y1, which in this case is a 12. We square that. Careful, watch your signs, and here's what I get. I get 3 minus 0, which of course is 3, but 3 squared would be a 9, so I get a 9 here. Minus 4. Add the opposite, so it's actually going to be a negative 4 plus a negative 12, which should be a minus 16. But then I would have to square that. So a negative 16 squared would be 256. So 256. Actually, you know what? Here, I'm sorry. I know, but just for the sake of completion, let me write this all out. So I wind up with a 3 squared, and then I wind up with a negative 16 squared. Let me show you how this works, right? Because that comes out negative 4 plus a minus 12, negative 16. Okay, so now we square those guys. 3 squared is 9. Negative 16 squared, 256. Distance is equal to, so 9 plus 256 would be 265, so the square root of 265, and again, you can throw that into a calculator, take the square root of 265, you'll get approximately, I got about 16.27. It'll be an irrational, a non-repeating decimal, because 256 is not a perfect square, but that's okay. We may have to round in some cases, especially when it comes to circles and ellipses and things like that. All right, I got a couple more example problems for you on the next page. Actually, this one right here, I apologize. Somehow I fat fingered something and copy and pasted the problem we just did is this one again. So just skip that one and let's jump straight to this one. All right, here's what we've got. I have a coordinate grid that I've placed over a map of California. Bakersfield is located at the point 37, so x is 3, y is negative 7, and Fresno is located at x equals negative 7, y equals 9, right? Right, if I were to take a map of California, lay a coordinate plane over top of it, right, the location of Bakersfield and Fresno would be those ordered pairs. Here's what I want to know. Tulare, a city in California, is halfway between Bakersfield and Fresno. Which is the closest to the distance in coordinate units from Bakersfield to Tulare. Please be very, very careful, right? What I've given you is the coordinate points for Bakersfield and Fresno. I want to know how far is it from a city, Tulare, that's halfway between Bakersfield and Fresno, right? So here, let me draw a quick little picture. I have Bakersfield, 3, negative 7, so Bakersfield would be down here. Fresno is negative 7, 9. Let's say Fresno's up here somewhere. There's Fresno. So Tulare is right there in the middle, right? Halfway between these two cities. I want to know how far, which is closest to the distance from Bakersfield to Tulare. So I want to know what is that distance right there. But I've given you the coordinates for Fresno and Bakersfield. So I think you can probably pretty quickly see what you're going to do is use the distance formula to find the entire distance, divide it by 2 to find the distance from Tulare to Bakersfield. Let's just jump right into it. Here we go. Point farthest to the left, I believe, is what I did. Yes. So this is going to be my x1, y1. This is going to be my x2, y2. And we're going to plug and chug. Distance is equal to... Okay, so it's going to be x2, which is 3, minus minus 7. Careful, watch your signs. Plus y2, which is a minus 7. Minus y1, 9. Square that. Take the square root, and let's see what happens here. I'm going to add the opposite, so that's going to give me a 10. squared, 10 squared, and then add the opposite 9, a negative 7, oh, I get negative 16 again, so plus negative 16 squared. Take the square root. All right, so here's what we've got. 100 squared is, of course, 100. We just did this one, negative 16 squared. Feel free to use a calculator if you need to. We said it was 256. Add those together. I get 356. So the square root of 356. 356. Okay, so now what happens is that comes out to be approximately 18.87 as a decimal. Again, use your calculator. 356 is not a perfect square, so just drop it into a calculator. Go ahead and just round it off at 2 decimal points for this example problem based on the numbers that you've been given. But keep in mind, that is the distance from Fresno to Bakersfield, right? That is this entire distance. I want the distance from Tulare to Bakersfield, which means I need to take that number, divide it by 2, and if you do that, you should get something very, very close to 9.5. Let's try another one of those. I've got one here, doing the exact same thing. We're going to drop a coordinate plane, this time over the state of Florida. Now, if you drop a coordinate plane over the state of Florida, they give you a couple of cities. They tell you St. Augustine would be at 313. Rockledge would be at 8, -1. These are all cities that are over on our eastern seaboard of Florida. And then what they're asking you for, Port Orange is halfway between St. Augustine and Rockledge. So which is closest to the distance, right? It's the exact same thing. Find the distance from St. Augustine to Rockledge, divide it by 2. That'll tell you how far it is from Port Orange to St. Augustine, or vice versa, St. Augustine to Port Orange. Let's go ahead and jump right into these. Here we go. Farthest to the left, there's going to be my x1, my y1, my x2, my y2, and we plug and chug. x2 is 8 minus 3 squared plus -1 minus 13 squared. Take the square root. Okay, so 8 minus 3 is going to give me 5, so that'll be a 5 squared, plus -1 and a -13, right? Add the opposite, but you wind up with a -14 squared. I'll take the square root of all those. 5 squared, right? I doubt you need a calculator for that. You should know that one. That's 25. Again, -14. If you're not familiar with that one, again, feel free to use a calculator. I get 196. 196 plus 25 is going to be 221. I'm taking the square root of 221. Again, not a perfect square. That's okay. We can use a calculator to approximate. I get 14.87. But again, remember, that is the distance from St. Augustine all the way down to Rockledge. But they want to know what is the distance from Port Orange to St. Augustine, right? What is that distance right there? But what you just found is the entire distance. So we'll go ahead and divide that guy by 2, and what you should get is something very, very close to 7.43. That'll be the distance from Port Orange to St. Augustine. All right, guys, thanks so much for joining me for this set of videos. Hopefully that's a really good refresher of both the midpoint and the distance formula. And remember, what we're going to do with them is use these guys later on when looking at our 4 types of conic sections to help us write equations for those conic sections, given whatever the information is that they give us. Thanks so much for joining me. Can't wait to see you next time. Bye.